optimize save event transaction. This is particularly important because you should know that this is not I'm the one that's telling the story, and I found the initial case, but it's a group effort, and it's impossible to do this on Sentry scale without the help of highly technical and highly skilled engineers. So as I told you, I'm on the processing team. My colleague Yarney and I wanted to find out how we can optimize Sentry's ingestion pipeline, and we realized that we spent one particular like $6,000 on this particular called save event transaction. And so there's definitely a room for events. So this is, I'm showing you the code so that you know and correlate the things that was happened. This is actually the code that you're seeing right now is before this optimization. So you will see all of those performance impacts and problems in here. So save event transaction is a salary queue, which is a RabbitMQ queue. It is called a lot of times. Whenever a transaction is called, it triggers a function called doSaveEvent, which is also triggered by different queues as well. But what this function does is that depending on the data and what we are receiving, it does some business impact. It processes the event. It calculates how much we are spending on processing event, and then it completes, and depending on the key structure, it either saves them or deletes it or sends it to a different queue for reprocessing. So as you can see, this is the perfect case for metrics, which is a product that you can see that the amount of time that it takes for each particular function and what is the impact and the execution duration of a single function is a value that you can get using products like metrics. So as you can see in the screen, we have this graph. It's between March 17 to March 27, March 20 to 27. It's the 1 week data. It shows you an interval of 1 hour. And it shows you that, as you can see in here, this is the self time, which means that any other, the save event transaction, that any function inside save event transaction that we don't particularly instrument takes this much amount of time. That's what self time is. And in total, in a week, we spend 1.37 weeks of computation power. This is possible because we have multiple processes that run the code. If it was one, and if it's single threaded, then it would be 1 week at most. But we can consume much more time, computation time in a week than we can because of parallelization and all of those technical improvements in the past couple of decades. As you can see, that in minimum, it takes 19 minutes. In maximum, it takes 3.6 hours per day, per hour, sorry, because the interval is 1 hour. And in total, we spend 1.37 weeks. We see these spikes. This means that whenever there's too much traffic coming on to the Sentry website, Sentry product, somehow we hit the upper limit, which most of the time it's CPU or memory or the network latency, the network layer that we see in our application, in our Sentry infrastructure, that becomes the bottleneck, which results in lower consumption ratio and higher latency. This is why we have these increase. So not knowing where to start, we realized that this is a problem by looking into save event transaction and inside the metrics. And we realized that, so how can we look into much more in depth about what the problem is? Because metrics helps you identify if there is a problem or a spike, or if there is something out of the blue that's happening in your application, depending on the time of the day, as well as depending on the certain metrics that you have. So in order to understand where we are and what's happening, before Sentry, what we would do is that we would go through this function one by one and saying, yeah, do save event call set event, set current event project. what it does, it sets the current project on the SDK scope. Then we scroll back, scroll down, and without profiling, we try to understand where we are and what are we, what might be the issue where we spend lots of time. This requires a lot of time, and it's open to issues, open to errors or mistakes, or simply due to lack of attention, we might lose some really important data. And that's why I use the trace view inside Sentry, which gives you, so by default, we for this particular path, we have been profiling where we are spending lots of money and lots of time. And this helped us to see this particular trace depending and understanding where we are spending lots of time. So let's dive into the graph, which shows us that we have an 8 seconds duration in this particular trace. So I really like this particular screen because it shows you where the problem is without reading any single thing, because like colors and bar graphs are always much more interesting than boring text, I guess. So if you see in here, we have an 8 seconds duration, and almost 95% of it, like 7.37 seconds, is spent on set subkeys. So again, before this, we would go and read one by one the code and where might be the problem is, and sometimes it cannot be that much impactful, but it's extremely obvious in this particular example. We see that we have a set subkeys, which takes 95% of the duration. Yes, we have other tasks. We have lots of Redis calls. We have multiple kill switch detections, canonical key dictionaries. We have feature flags, checking if the flag is enabled or not. We have a database call, multiple Redis calls, and then we have this set subkeys. So what does the set subkeys does? Set subkeys is, so before diving into set subkeys, I want to tell you the infrastructure, which is open in GitHub. So I'm not revealing anything secret, but it's all open source. We are using Redis and Memcache for caching certain things. We use Memcache for particular area where the data that we store in Memcache is volatile, can be removed, and it doesn't impact the workload or the stability of the company or the product. So in this particular example, setup subkeys actually stores data in Memcache and it saves it. So in order to save any data in Memcache, we basically pass a value like this, which is we have a key of none, and then it has a value. And then for certain keys, certain paths, we have reprocessing and so on and so forth. So every time a data gets called, we call set bytes, which basically converts this payload into bytes, which means it requires encoding and later decoding. And then it basically calls set cache item. As you can see it in here, before this particular line is what causes the most impact. So at this point, we want to understand the actual impact of set subkeys. So this particular trace shows us that we spend 95% on set subkeys, but this might be one of those cases where our CPU usage, our traffic has lots of spike, and due to that spike, we have an edge case that might result in high number of duration in while saving something to Memcache. This is extremely possible because this is a distributed system. This means that any particular area that might cause issues might impact the outcome of this parent function. For example, if there is a particular problem in Redis, we will see all of those Redis calls taking a lot more than what it is right now. So we wanted to make sure that this is not a one-time thing. This is an actual problem. The best way to understand this is to see the impact of particular using metrics and understand what is the ratio of save event transaction time versus the time that it calls node store, which is the memcache. So you will see that the yellow is the ratio. You will see that these three values, one of them is 1.38 weeks, one of them is 5.93 days, and there's a direct correlation between the time that we call save event transaction and the time that it takes to execute set subkeys. This means that, so if you look into every single comparison, we will see that they're all related to each other. This means that this is not a one-time thing. This is a problem that we see constantly, and it's not caused by a simple glitch or a simple bug or a simple traffic spike. You will see that the transaction we spend a minimum of 27% and a maximum of 81% on setting the cache. This minimum and maximum is extremely high, not because of infrastructure related issues, but because of the variety of the transactions that we get. Because you can add any data inside this transaction, and the structure of that data, the transaction data, might change. And depending on that, if it's too big, then encoding will take too much time. If it's too small, then the encoding will take less time. And because of that, saving in the memcache would be a lot faster. Because if you save small things, it's going to be super fast. But if you save a 1 gigabyte of data, then it will take a lot more time to do that. To summarize, on average, we spend 51% of the time processing a transaction on setting the cache. In financial terms, this means that we spend roughly $3,060 per week on setting the cache. And that's by, in the beginning, I told you that it's $6,000. So average of 51% of the time results in $3,000 setting the cache. And that's only for setting the cache. So before diving into the solutions, into what actually led to this exact moment, is that the goal was to improve save event transaction, and we realized something much more major in our application layer, which results in lots of setting cache on any kind of transaction that we get, but we don't know if we need that particular cache. Maybe we are writing it, but we are not reading it. Maybe we can move it to secondary. Maybe we can just remove it. So this is the result of this particular work. So saving Sentry from save events is basically where we are right now. So we want to reduce. So the first thing is be deliberate about when we set the cache. Second is improve the balanced distribution of traffic between memcache servers. And 3, enable background threads for third-party pools. And 4, move away from 2M proxy to alternatives. So 2M proxy is the proxy that distributes workload between memcache servers. This means that if I have a 10 memcache server, I wanted to distribute them equally or according to a certain rule so that I don't particularly focus on a particular server. So this particular spike on save event transaction and this particular spike in here, so the save event transaction spike and memcache setting spike is exactly the same. This means that our bottleneck is memcache, and this means that depending on the traffic that we get, our memcache servers are getting exhausted, and we are hitting the machine limits, which is the CPU or the memory, and this is causing the latency. So this means that our proxy that distributes the workload are not doing its job correctly, which hints away that maybe the twin proxy that we use is not the correct solution here. So after careful consideration, we decided that instead of setting the cache with every transaction requiring a separate write operation, we could just set the cache during the first read operation. So if you look into the particulars pull request, that disabling setting cache on write, we will see that we had this function called set cache item inside set subkeys, but with this particular change, we put it behind a feature flag. This means that we can toggle on and off on production and depending on the impact of this change. So we realize that whenever you call, so if I look into the callers of this function, we have the set function. We also have a get multi. So whenever you want to read something from memcache, if it's not available, then it actually reads it, it decodes it, and then it puts it into cache if that data is not available. So this means that in the first read, if it's not cached, we cache it already. So whenever we want to write something like transactions, we don't need to save that, we don't need to cache that. So this is the whole optimization that results in a huge impact. To summarize once again, before this particular optimization, we were writing to cache on every single transaction. But most of the time, we didn't even need that data. So instead of reading and understanding and looking into probably a million line worth of project, Sentry project, we moved this particular setting cache operation inside the first read instead of the write. So as a result, you will see that before this particular line, it was almost 300, 400 millisecond line operation, millisecond executed operation. And right now it is P95 is 127 milliseconds. This is a huge improvement, which results in the time getting dropped from 300 milliseconds to under 100 milliseconds. And as a result of this particular change, because this set subkeys is called on multiple different places at the same time, whenever you need something, whenever you need to set a cache, we were calling this particular function all over again. And as a result, this resulted in decreasing the duration and processing performance of both process increment function, save event function, and many other places, because memcache is not only used on the ingestion pipeline, but it's also used on API layers. As you can see in this particular line, 573 milliseconds is decreased to 440 milliseconds. So the only thing, without reading the whole code, I went there, I opened Sentry, I looked into this particular metrics. Okay, I understand what the problem is. I dived into the code. I realized that it's set subkeys. I experimented and said that I wanted to validate, before writing a single line of code, I wanted to validate if this was the correct problem. And then it was. And then I opened this particular PR, which changed the 3 lines of code. And right now, here we are impacting the whole processing pipeline of Sentry. So this is where things got interesting. So up until right now, it was me and Yerney who in the beginning experimented with where we are and what are we doing, and like why are we spending so much time on this particular function. And then as a result of these changes, 2 of my colleagues in ops team, Anton and Alex, also found an issue with Twem proxy, because as a result of this particular spikes, it resulted in saying that we had a particular problem in our infrastructure and distributing workload in memcache servers. So as a result of that, we changed our Kubernetes config to have a load balancer on top of Twem proxy, which distributed the workload accordingly. And as a result, you will see that the total percentage of CPU time spent in user space decreased significantly. This is the particular time that they made this change. And before that, the spikes were much more stable. This small experiment, which adding a load balancer on top of the Twem proxy save, resulted in a huge decrease in save event, P95. Before that, it was 180 milliseconds, and right now it's 120 milliseconds. So this whole huge decrease was a result of it was a result of Sentry using only a couple of Memcache servers, even though we had maybe 10 or 20 different Memcache servers. And because of that, if we distribute the workload correctly, the CPU times and the latency is decreased. And as a result, everybody's happy, including our API and our processing pipeline. As a result of this, again, this Kubernetes change, it also decreased save event duration by 10 milliseconds, which is 13%. And it also decreased save event transaction, which we were trying so much to optimize by from 125 milliseconds to 67. So in the beginning, we were at 300 milliseconds. Right now, we are at 67 milliseconds. And as a function that gets called by 250 million times per second, this impact is huge because right now we are needing less memory, less CPU, less computation power to consume the same amount of events per second. So as a result, we realized that certain third-party tools were also causing problems because they were operating in the same thread and enabling background thread ingestion. This also helped us to improve our I/O blocking. So because Python was operating in a single thread, whenever we wanted to send metrics to third-party tools, it was blocking the main thread. And because of that, the synchronous operations that's happening at the same time were getting impacted. So moving it to a different thread resulted in 30% of the whole transaction. So it was 75 to 80 milliseconds beforehand. Right now it's 65. So we have less than 15% improve. So while we were doing that and realizing certain things about save event transaction, one of our security engineers, Alex Ternasov, ran a quick benchmark to understand, but can we do more? The question is, as you can see, the first benchmark that we run is accessing this particular Memcache server directly takes 1.02 millisecond. So 1 millisecond. But if we access that Memcache server through a twin proxy, like a proxy, it takes 3.45 milliseconds. And we are spending almost 3 times more for a single transaction because we have a proxy on top of it. So proxy, yes, we have to use it. We cannot get rid of it, but this doesn't mean that we cannot experiment with different routers. So because we also had Mac router in our whole infrastructure, right now we have the option to move from twin proxy to Mac router. And one of our engineers on the processing team, Arpad Borsos, is working on removing it and distributing workload from Python. And as a result of its work, we can reduce the overhead that Alex Ternasov found. So did metrics really help us save time and money? So here's the overview of the save event transaction P95 with all of these optimizations that was happening. In the beginning, it was 300 milliseconds. Right now, it's less than 100, maybe 60, 70 milliseconds on P95. And P99 is also showing similar signs. So, so if you want, if you're inspired to try metrics, I'm more than happy to invite you to go try it right now. But before closing this call, I want to show you how, and I want to give you a quick demo about how actually metrics UI shows us in real time what we can do and what we can what other things that we can do. And also I want to show another product that I always use in order to understand where we are and how we're spending time. So this particular UI in metrics will give you, so I'm in the demo Sentry account right now, so this is not production data. Unfortunately, due to privacy and security concerns, I couldn't show you the production data that resulted in this particular optimization. But it will give you the idea and the gist about what you can do right now. So we have these checkout field and checkout events. And let's say you have a particular Flask application and you want to know if you have a certain problems in checkout situation. So you have a e-commerce website, people buy certain stuffs, and depending on your vendors or your infrastructure or certain things, the amount of checkout failed events might increase or decrease, and so on and so forth. So this will give you the idea. If you look into like weekly, this will give you that yes, it's pretty stable. This means that we don't have a specific bug. We don't have anything related to anything that can correlate us and say that, yeah, we have a problem and we need to fix it. And the thing is, it also supports multiple other custom events that we can get and we can understand. We can see the span duration of particular database calls depending on, yes, where we are and what's the distribution and what's the minimum, what's the maximum. And it also, as I told you in the blog post, it gives you the data to understand if this is a one-time problem or if this is a particular problem that happens on a particular day or depending on the spike that we get. And last, I want to show you queries, which is my favorite to understand where we are and what kind of database queries that we make in our application. And as a result, what kind of problems or what kind of impact we have on our database service. Because in the year of 2024, it's almost impossible to have an application that doesn't have a database. And most of the time, we depend on highly technical and highly complex products to understand how many times we are calling this particular minute, what's the average duration, how much time are we spending, should we optimize, should we work on this particular thing. And the good side is, right now you can. This particular function, select starts from reviews and product bundles, which gives you the reviews as an array. This is, I can see the queries per minute called, and I can see the average duration, and I can see where it's called from. If I go to this particular get organization, I will see that on the get organization API endpoint, this gets called, and on a products, yes, this gets called as well. So in the future, there are lots of opportunities in this particular area where you can explain and analyze your SQL calls, and we can and we will give optimization opportunities and give you hints about, yes, this particular SQL statement makes a sequential call, and as a result of that, yes, if you add this particular index, it will have this much impact, and then it will be a really life-changing UI. So thank you for listening, and yeah, I will stop sharing for now, and we can go to the questions, I guess.
Awesome.
Q&A section.
Thank you, Yagiz. That was really good, insightful. Awesome. Thank you. What you did fail to mention is that this is not the first optimization that you actually did in Sentry. You've done what, over how many were there?
I don't know, more than 100, I guess.
More than 100, yeah. And like in 400K.
Yeah.
US.
Since November, I mostly worked on performance, and this particular optimization resulted in $160,000 per year, and I have more that resulted in almost $500,000 per year, which saved Sentry.
That's crazy. That is impressive.
And the thing is, I didn't had to use any other tool. Like, I'm not telling you because I'm working at Sentry, because this is how impactful and how helpful a product Sentry is. Without reading the code, without even running the code on my local machine, if you look into the product on a particular path, and if you connect the dots, not dots that are too far away, but close to each other, then it's extremely easy to steal my job. So yeah, frightening and amazing at the same time.
Awesome. Yeah. Thank you, Yagiz. So we have a couple of questions, but in the meantime, for everyone who is wondering, yeah, drop your questions in the Q&A. we'll go, answer each and every one of them. Right now the Q&A is cricket, so let's see some questions there. But if not, we'll just finish earlier. So we got two questions. I see something about the metrics API changing soon. Is the new API available in the beta? I know that it's the metrics API is coming in, it's coming out in a few months. So keep an eye on it. And the next question is, how do you even add these events inside metrics for your app? And yeah, Yagiz, you want to take that?
Yeah, I can answer that. So there's two approaches that you can take. One of them is profiling, which is meaning that you can enable a profiler in the Sentry SDK, depending on the technology that you use, which automatically grabs and captures the traces every X millisecond and sends that data to Sentry. This might be a little bit impactful if you are looking for high performance issues, but it is extremely important to beneficial if you enable it while optimizing certain things. The other thing is that you can go ahead and start sending transactions and calling Sentry SDK transaction function on every single function that you want to trace, and Sentry will correlate that data and show you in the trace view. If we didn't enable if we didn't use profilers, we would use trace view, which enables us to use transactions, and it doesn't have that much kind of impact on performance, but it will give you the insight about what we want to measure, and it gives you the ability to configure what we want to capture and send it to Sentry.
Awesome, thank you, Yagiz. Well, I guess we don't have any questions. Yeah, it's all clear.
Yep.
Oh, there we go.
Yep.
I was wondering if you have any stats on how much compute time is used processing or saving Sentry metrics for Sentry. Like how expensive is using metrics for Sentry? Is that something that we have?
So how expensive is using metrics for Sentry? I don't have that data that I can. Even if I did, I think that would be a privileged information. But yeah, I don't have that data. But how much compute time is used processing, saving Sentry metrics for Sentry? Yeah, unfortunately I don't have that data.
Awesome, and we also had one more for the URL for the blog. Yeah, the Sentry Workshop account posted in the chat for everyone, and I also answered it in the Q&A. But that's all for now. Anyone has any more questions? Say something in the chat so we don't miss out if you're already typing.
If you have questions in the future regarding this workshop, you can always reach out to me by my Twitter account or my email. I'm more than happy to answer and help you.
Awesome. Okay, so if we don't have any questions, yeah. Thank you, Yagiz, for...
There's two questions. One of them is profiling is the only thing that I need to enable in our app, and it should start showing versus yes. So, for example, if you use the Node SDK, you can enable profiling. You can install profiling Node package and enable profiler. Then it will show us the data for the trace view and the profilers. But for metrics, you have to use the Sentry metrics and say that yes, what do you want to measure? You want to measure the transactions. You want to measure like whatever you want to measure. You need to call that. But for certain, if you enable profilers, it will show you most of the data that you also measure in your profile, which says that yes, if you enable profiling, then it will show metrics as well. The other question is how much data is generated for logging to Sentry? I'm not really quite sure how to answer that question. How much data? It's like 2 kilograms of data. I don't know how to answer that. Yeah. If there's anything specific, I'm more than happy to answer. And yeah, so thank you again for coming, and
Yeah, thank you, Yagiz. This was a really good presentation. I loved it. And I can see
thank
people
you.
in the chat also appreciated your presentation. So thanks again for running us through, the adventure of using Sentry to debug Sentry. All right, so yeah, everyone who is interested to get started with Sentry, follow the link on the screen, sentry.io/signup. It's easy to get started. And we also have our demo, sentry.io/demo. If you don't want to install Sentry in a project, instead of if you just want to see how the dashboard looks like, what type of data you're getting, go check out the demo. Yeah, and thank you all for tuning in. This was a really good workshop. Again, thank you, Yagiz, for running us
Thank
through
you.
the blog, the blog, and also everything you did